In this video, I'm going to start discussing ionic compounds. Ionic compounds are made of positive and negative charged ions. Ionic compounds are made of a metal and a nonmetal. Remember, metals are usually going to lose the electron and become positively charged. Nonmetals are going to gain the electrons and become negatively charged. And so we can think of something like a metal like sodium and a nonmetal like chlorine gas. And so ionic bonds can form between sodium and chlorine, and these are these strong electrical attractions between the opposite charges. So when we mix sodium and chlorine, we can get sodium chloride, which is just table salt. So creating a chemical bond changes the properties of the two elements. Sodium is a very reactive metal, it can be dangerous, and chlorine gas is a toxic gas. But as we see when we put the two of them together, it makes sodium chloride, which is something we eat every day. So two dangerous chemicals, such as sodium metal and chlorine gas, when ionically bound together, change into a relatively harmless chemical that we encounter on a daily basis, which is the sodium chloride or table salt. So when atoms gain or lose electrons to form compounds, ions are formed. Remember, the metal will lose electrons, the nonmetal will gain electrons. That will make the metal positively charged, the nonmetal negatively charged. So ionic bonds occur when valence electrons of atoms of a metal are transferred to atoms of nonmetals. And then we get the ionic bond, which occurs through electrostatic attraction of the two oppositely charged ions. So remember, we can look at our table and we can come up with a regular charge for them. We'll see in a couple videos after this one that some of the elements, the transition metals, do not have a predictable or reliable charge. They can take on multiple variable different charges. But things in the first column will always take on a +1 charge, the second column +2, and then the 13th column, which is the 3A of our main group elements, always takes on +3. Then the carbon column, I always call it kind of the wild card column. It can take on multiple different charges. Then the 15th column, which is main group 5A, that's the nitrogen column, always gets -3, the oxygen column -2, and the fluorine column -1. So these are pretty reliable and predictable charges for a lot of the elements in these columns here. And so the cation is the element that would have the positive charge, is always written first when we're coming up with our chemical formula. The anion, which is the element that would have the negative charge, is always second when we're writing our chemical formula. So the number of each element present must be such that the charges cancel out. So we have the positive and the negative charges. They have to cancel out when they come together to the neutral compound. And so that means we have to have a certain number of the cations and a certain number of the anions. And the number must be such that the charges on them cancel out and we get a neutral compound. So for instance, sodium has a +1 charge and chloride has a -1 charge, and so that means we only need a single sodium and a single chloride in order to make the neutral compound NaCl. And so we can think about it this way. If we have our sodium, which has 1 electron in its outermost shell, and chlorine, which has 7 in its outermost shell, the sodium gives up its electron to the chlorine to make chloride, and that's because the sodium has low ionization energy, and so is much more likely to give up the electron. Chlorine has high ionization energy, and so is much less likely to give up an electron, but it also has high electron affinity, so it's much more likely to take on an electron. And then when we have that electron transfer, the sodium becomes positively charged, the chlorine negatively charged, and then we have the electrostatic attraction. And so we see that the positive on the sodium is canceled out with the negative on the chloride. Similarly, we can have magnesium, which has 2 in its outermost shell, and then 2 chlorines, both with 7 in their outermost shell. The magnesium gives up an electron, 1 to each of the chlorines, and so that's because, again, the magnesium has a low ionization energy, and the chlorines have a high ionization energy and a high electron affinity. And when that happens, the magnesium takes on a 2+ charge, and the chlorines take on -1 charges. So that means we need 2 of the -1 charges to cancel out the +2 charge on the magnesium, and that will give us a neutral MgCl2. And similarly, we can have 2 sodiums and 1 sulfur, so the sodiums have the 1 electron in their outermost shell. The sulfur has 6, so the sulfur can take on 2 more in order to get its full octet. And so when that happens, the sodium will become positively charged, the sulfur -2 charged, so we need 2 sodiums for 1 sulfur in order to get the charges to cancel out, and that will give us the neutral Na2S. So again, we need 2 of these sodiums and only 1 of these sulfurs. So when we are writing formulas for ionic compounds, these are kind of the steps here. We want to identify the cation and the anion, so the cation being what would be positively charged, the anion negatively charged. We want to balance the charges, so we want to have a number of the cations and a number of the anions such that the charges will cancel out and end up being 0. And the third step is to just write the formula cation first using the subscripts from the charge balance. So remember when we saw before the Na2S, that's because we had 2 sodiums for that sodium sulfide. If we think of something like calcium chloride, which is made from calcium and chlorine, we first want to find out what our cation and our anions are. So calcium is going to be over here, that's in the +2 column, and chloride is over here in the -1 column. So that means we have the +2 calcium and the -1 chloride. So the calcium ions always have the +2 charge. The chloride ions always have a -1 charge. Therefore, we need 2 of the chlorides to cancel out 1 of the calciums. So we want to essentially do this formula here and get it equal to 0. So we need 1 of these +2s and 2 of these -1s to get 0. So this gives us the formula CaCl2, and a few things to notice about this formula. So the first one is that we do not actually put the charges in the formula. A lot of students, when they're first learning this, try putting the charges inside the formula, but we do not want to list the charges in our neutral chemical formula. The other thing to notice is that we have this subscript here, and this indicates how many chlorides there are present in the compound. So the subscript only applies to one of the elements, and it's the one directly before it. So it does not apply to the entire compound, only the element that comes directly before it. So to look at this again, we can think of aluminum oxide. This is made from aluminum and oxygen. So aluminum is in this column, that's our +3 column. So aluminum will have a +3 charge. And oxygen is in the -2 column, so that will give it a -2 charge. So that means that the aluminum ions always have a +3 charge. The oxide ions always a -2 charge. Therefore, we need 3 of the O2 minuses to cancel out 2 of the Al3 pluses. So if we want this +3, we need to multiply it by 2, and this -2 multiply it by 3, and then add them together, and that will get us 0, which would give us our neutral compound. So this gives us the formula Al2O3, and some things to notice about this. Again, the charges are not listed in the neutral compound, but also the subscripts number indicates how many aluminum and oxides are present in the compound. So we see there is one that comes after the aluminum that applies only to the aluminum, then one that comes after the oxygen that only applies to the oxygen. So there are 2 aluminums and 3 oxygens in this compound, Al2O3. But anyway, that was everything I wanted to talk about in this video. I hope you found that helpful, and I will see you in the next one.